Hello there, once again, welcome to our science lesson. So remember, previously we were looking at some questions related to disease host relationships. But we were able to find out that disease host relationship is the same as pathogen host relationship. Pathogen host. Because we are looking at biotic factors, therefore we have to find out how two or more organisms are interacting to form a relationship which has effect on their distribution and abundance. So we have the pathogen and the host. It's the pathogen that will cause a disease to the host. And the host, so most of the time in this kind of relationship, the host will be getting some adverse effects. It could lead to death of the host if the pathogen is highly virulent, or sometimes the host can decrease in population. But we also have some benefits that we are going to find out, that if the host does not die, for instance, and it has been invaded by the pathogen, then it means it has developed some resistance, or the immune system has been able to serve it very well. So in the immune system is able to develop resistance. So let us continually look at some few questions to get better on this. So our last question was, name some prohibited items that cannot be brought into Australia. We named them as most common foodstuffs that are animal products and sometimes plant products like eggs. We have juices, fresh fruits. We also looked at vegetables, the bee products like honey, meat, milk, and others. We also mentioned some live organisms, live animals, and plant parts like roots, like stems, and cuttings, and other materials that are inert, like sand, like soil. Sometimes people come with sand for different purposes, and then packing material. So the other question, part B of that question. So the first question was on part the quarantine, Australian quarantine and inspection system. The service inspects all goods and services. So that's where part A came from. Now we move to part B. Explain the importance of keeping pathogens from other countries. Explain the importance of keeping pathogens from other countries out of Australia. Keeping pathogens from other countries out of Australia. So it should be known, this has been the major role of the Australian quarantine and inspection service team, so that most of the pathogen from other countries do not get into Australia. So the question is, what is the essence of that? What is the significance of such efforts? Now, Australia as a country is isolated from the rest of the world. So from the evolutionary point of view, we had geographical isolation of organisms. There was geographical isolation of organisms when the drifting of the earth happened. Remember the theory that led to formation of different continents, Australia being part of that land. So we had geographical isolation of the organisms to different environment. And in isolation leads to evolution, to adaptation to that kind of ecosystem, and then later they become a different kind of a species. So geographical isolation of organisms led to evolution. So the organisms evolved. So organisms in Australia evolved differently. Differently from other organisms of the world. So having different evolution mechanism due to isolation, it means the gene pools in different organisms of the world shall not be same to those organisms that are found in Australia due to isolation that led to different evolution. So because of that, if we are going to have pathogen from other continents or other countries getting into Australia, they may have adverse effect on native plants and native animals that are found in Australia. This may have it can cause disastrous effects on native plants and animals. So those plants that have evolved, that were isolated and evolved from Australia, they may be wiped out from this kind of pathogens because they have different evolution mechanism, they have different lines of evolution. Therefore, they might be more competitive, successful competitors than the rest. A very good example of pathogens that are usually taken care of by the AQIS is majorly rabies, the pathogen that causes rabies, and the one that causes food and mouth disease. Now, for human beings, rabies also affect human beings. But again, for instance, you realize that in Africa, those people that live in tropical Africa, they're able to live with malaria. There is a host pathogen kind of adaptation so that there's a balance because they are able to evolve together. But if somebody comes in from any other place, the effect of malaria is very devastating on such people. So it is the same concept here. Then part C, the Australian Quarantine Inspection Service monitors the movement of plants and animals across Australia. Of plants and animals across Australia. Between states and region. Give an example why this is necessary. Across Australia, between states and regions. Give a reason why this is important. So we have said most of the medium or the carrying material for pathogens are plants, live animals, materials for plants like fruits, like juices, and other materials. So if we have a region A, if a region A is infested with the disease X, let us use such, and you want to prevent the disease from crossing to a region, remember it states and region B, then there must be very strict ways of preventing the crossing of plants, animal, and their products to such area, because they could be contaminated and it's going to spread the problem from this region A because it is infested with disease X to that part. So that is why the movement itself in fact is called a quarantine, restricted movement of plants and animals, so that if they are infected, then that disease is only confined in this area, and the efforts for control or for controlling the spread of the disease is carried mainly in such an area. Because if it spreads to the other end, it becomes a problem in areas that it was not a problem. Therefore, the magnitude of efforts to control the spread and even treat the disease will be even large. And remember, this comes with a cost. So this is a way of avoiding such cost. For instance, we have the aphid. We have the aphid that carries a disease called phylloxera disease, or causes this disease to grapevines. Specifically in Eastern Australia. So this disease is found in Eastern Australia. So to prevent the spread of disease to other parts of Australia, the Western and South Australia, there must be restricted movement of these grapevines or the fruits, so that it cannot spread to other areas, the Eastern and the Southern Australian parts. So it is in essence just to prevent the spread of the disease, so that when it is confined in one area, it becomes very easy to control it and even treat the plants and animals that are affected. Then question 3, I think it was 4, explain why in many cases the hosts the host pathogen relationship does not seriously harm either the host or pathogen. So there is a host pathogen relationship, but in other words, there must be a balance so that we do not have very harmful effect on both the host and pathogen, but specifically the host, because pathogen invades the host. If it's going to be so virulent that it causes death of the host, there will be problems. So explain why. This is important because it's a beneficial relationship to both. It is a beneficial relationship to both host and pathogen. So the question is, how does it become beneficial? And we already said that pathogen causes diseases to host. So let us find out how the pathogen can benefit from this. Now, the pathogen can only benefit from this relationship if there's a balance, so that the host, the pathogen, does not cause the death of the host. Remember, pathogen here is obtaining some benefit from the host. If it is a bacteria in your body, it is getting shelter, it is getting nutrients from you, and it is also getting a site for reproduction. So it is increasing in population. So if the host dies, in this case, if a pathogen invades a host and the host dies, then it means the pathogen is also going to die, unless if it is going to be transmitted to another host. So it becomes beneficial to the pathogen. If the host does not die, since it will continually obtain resources like shelter and nutrients. So in this case, the pathogen is safe because the host is still alive. But now let us ask ourselves another question. How does the host benefit from this? The host also benefits, because suppose we have a flock of hosts and they are increasing in number, but the carrying capacity is just about to be exited, and then a disease comes in. Now the population of the host will decrease. When it decreases, then the population will be within the carrying capacity of the ecosystem. So in other terms, we are saying the host, because of the pathogen, it leads to slight reduction in the population of the host, so that now it can match with the carrying capacity of the ecosystem. So for the host, pathogens leads to reduction in population, decrease in population within or to the carrying capacity of the ecosystem. So it means the host has benefited a little bit, not just as one organism, but as a population as a whole, such that the threshold of the carrying capacity of the ecosystem is not exceeded. Because if it's exceeded, there will be drastic drop in the host population as compared to if it was dropped or if it decreased due to the effect of pathogen. So this creates a balance in the ecosystem. Even where we have all other factors in an ecosystem, where we have a flock of animals and all other factors are constant, they are well supplied, there are no predators, there is no competition, and population is increasing, it is likely that it will go beyond carrying capacity. That is where the pathogens comes in, leading to decrease in population, not too much, but just to the level where for instance, where the ecosystem can be able to continually support the population. So at that point, if we are drawing, I'll draw a larger one. If this axis for population and time, that point is called the carrying capacity, where population cannot go beyond that. But if it goes beyond that, there'll be a problem in that ecosystem. Now, the other way in which the host benefits, sometime or most of the time the host is invaded with a pathogen, but it's not a must that the pathogen must die. The host must die because of the pathogen. So how will the host now benefit from this? We have what you call the immune system. Once a pathogen has been introduced to the body for the first time, the immune system is able to produce antibodies against the pathogen because it's a form of antigen, and the structure of the pathogen, being an antigen, is retained within the memory cells of the host. When it's retained in the memory cells of the host, any other subsequent attacks by the same pathogen, it will be recalled, or it will be recognized, or it will be remembered, and then the host is able to fight the pathogen in the same way it did the first time. So in other words, through attacks of the pathogen to the host sometimes, if it does not die and it gets healed or it survives the pathogen, it's able to acquire resistance. So the host acquires resistance if it survives. So the word is if it survives the pathogen attacks, the invasion by pathogen. Now, because of these three concepts, it creates a balance between the host and pathogen, such that we still have pathogens that are important for ecological balance, that is balancing the population of the host. But as the host also dies, it also goes together with the pathogens, unless they are transmitted to another host. So there is a balance. Now, we address the question of distribution. How is the host-pathogen relationship affecting distribution? You'll find that in areas or in ecosystem where we have high pathogens or high pathogenicity, we shall have fewer hosts because they are too much. They are decreasing the population of the host too much, therefore fewer of the same. So it has reduced the number, the abundance of the hosts. And then with the time also, the host will tend to avoid such areas where we have a lot of pathogens. Then question 5, complete the table. Complete the table to summarize examples of types of relationships. To summarize examples of types of relationships. So we shall have relationship here, this column. And then you have effect on organism. Then example. So for any relationship to be there, you must have species A, species B. So let us organism A, organism B, that is organism B. Because you cannot use species, because sometimes even this type of relationship is between same type of species. So the first relationship, we have talked about many, we can just have few. We have predator-prey relationship. So what is the effect? Let us assume that first organism is a predator, and then the second one is a prey. Remember we talked about this. The compound word was predation, where we have an organism called predator, a carnivore, which depends on another organism called the prey as a source of food. So predator, how will it have, or how will it gain in this relationship? We already know that it gains by getting nutrients. Gains by getting nutrients. But the prey is going to lose death, the effect, death of the organism B, or we can say being eaten. So there are several examples. The Australian examples, we have a predator called the dingo. Dingo usually preys on birds called the wallaby. And then we have the barn owl, the owls. Barn owl usually preys on mice. We have parasites, parasitism. So we said parasitism, we are again going to have two organisms, one called the parasite and the other one called the host. So how does the parasite, how does it gain, or what is the effect of parasite in this relationship? We have found out that it deprives, it gets nutrients. It gets nutrients from the host. It also gets shelter, obtains shelter from the host, obtains shelter from the host. But if it is the host, remember parasite, host relationship. The host now is the one that is harmed. It is going to lose. So it is deprived of nutrients. Deprived of nutrients. Now when the host is deprived of nutrients, it gets emaciated and weak. So we have emaciation. This also comes with anemia, because some parasites, if they are going to live on the skin of the organism, the other organism, or inside, they are going to suck blood. So it also comes with effect like organism B, which is the host, getting anemic. The other effect comes with transmission of diseases. Some of the parasites transmit diseases, like if it is a mosquito, it will transmit disease or disease-causing organism, plasmodium, hence malaria. So it acquires, it becomes diseased. So examples, we can give very common example like we have the tick-cattle relationship. So we are saying we have organism B, which in this case the host will be deprived of nutrients, and the effect of this is emaciation, because the nutrients are supposed to build the body of the organism and several other functions. Due to sucking of blood, again, it becomes anemic and they transmit diseases. Very good example is the mosquito transmitting Plasmodium, which causes malaria. An example of this parasite-host relationship could be the tick and cattle. We have the flea and rat. So the cattle is on this side is the host. Tick, parasite, cattle, the host. Flea, the parasite. And then the rat being the host. You have several tapeworm and dog relationship, such that the tapeworm is the parasite and dog is the host. Other relationship that we have come across is intraspecific competition. Now we said that competition is when organisms in the same ecosystem demand for the same resources, but those resources are limited in supply. We shall have competition. But again, we said if that competition is within the same species, members of the same species, if it is human beings alone, then it's called intra, within the same. So because they are of the same species, then that demarcation will not exist, but the effect will be on the population of the organism. So in intraspecific competition, what happens if there is enough supply of nutrients, population usually increases. When population increases up to a certain level, the environment cannot continually support the same population. What will happen? There will be a decrease. So a decrease in population. So the effect is decrease in population if organisms continually reproduce beyond carrying capacity of the ecosystem. So when it goes beyond the carrying capacity of the ecosystem, then they drop the effect on the organism, decrease in population. But remember we said intraspecific competition is safe. It's a safe relationship such that they will decrease, but it does not lead to extinction of the organism because it will just decrease. Then when resources are enough, when there's normal supply, the population surges back to its normal point. Very good example is the male peacocks. When male peacocks are competing for female peacocks, they are called peahens. They are competing for peahens. There's that competition. Some of them, they'll fight, and in the process, there's decrease in population, but without actually eliminating the whole species. So we can have several examples, even red kangaroos. We have the red kangaroos competing for grass. So they are of the same species, So because of that, maybe they have increased in population beyond the carrying capacity of the ecosystem. The effect is decrease in population. Interspecific competition. Interspecific competition. Remember, we also talked about this. If it is between members of different species, then we are having organism B and A. So we have a species A and a species B. So the effect is this. For interspecific competition, if species A is a successful competitor, in other words, it has all the adaptive mechanism to enable it survive in the ecosystem. Remember, we talked about those adaptive mechanisms like high reproductive potential. So if organism A has high ability to reproduce than B, is going to produce many of A which will outcompete B. So here the effect is if it has successful competitive features, the effect will be increase in population. Increase in population. Because of successful, useful chemistry, or is able to produce useful variation. Remember, we talked about those variation, adaptation, the high ability to reproduce, able to migrate to other areas, able to use different food sources. Instead of just maintaining same food sources, like we can have herbivores partitioning their resources, such that we have those that will be feeding on the upper canopies of trees, while the others are feeding on the vegetation on the ground. That's why we classify herbivores as grazers and browsers. So some can be browsers, others can be grazers. That is a successful behavior. But if we have another organism B with unsuccessful variation, characteristic, a variation is simply a characteristic, then it's not going to be able to survive the stiff competition it will be brought about by A. So the effect is decrease in population. Decrease in population of B. That's why we are talking of interspecific, two species, A and B. So one increases, the other one decreases, depending on the type of variation that it is putting forward. So a common example, we can use the grey kangaroos and sheep. Sheep here is the one that will suffer the effect because it has less successful variation. Now, in our lesson, we also used Paramecium caudatum and Paramecium aurelia. So we have Paramecium, I'll use P for Paramecium, and then caudatum, that species, and Paramecium aurelia. We found out that aurelia has high reproductive potential than caudatum. Therefore, it outcompetes caudatum, even leading to extinction. So, in essence, we said interspecific competition is very stiff. It has disastrous effect, such that it leads to exclusive competition. Then others, we have pollinators and disease pathogens. So pollinators, 5. Pollination or pollinators. So in this kind of relationship, we must have the agents for pollination, which are animals. They could be insects and mammals. And then we have other organism B, which are the plants that releases the pollen grains and also receives the pollen grains. So in this case, the organism A for pollinators will be animals that are agents of pollination. So the effect on agent of pollination, they are going to carry, they transfer pollen. They transfer pollen during foraging, especially for insects, as they move from one flower to another. We call that foraging, movement from one flower to another. As they feed on nectar, the pollen grains stick on their bodies if they're insects, and then they are transferred to another flower. So that is called either cross-pollination or self-pollination. Here the other organism is the plant or flower. Plant. We know that the plant must have the flower to allow the pollination. The plant that releases, so it releases pollen, releases and receives pollen. So we have several examples where birds are doing that, where bees are doing that. You can have one example, bees and flowers of different plants. Then the last relationship we can look at is disease host. Disease host. Now for disease host, you already know that the other organism that causes disease is the pathogen. So the pathogen. Pathogen here usually transmits disease or causes. Pathogen causes disease. And as it causes disease, we also have other effects on itself or on the host. You're going to have deprivation of normal functioning of the body. So the host is not able to carry out its functions. And several others. We have already said that the pathogen can also obtain nutrients and several other things. So we can use an example. We have a disease or a pathogen called the myxoma virus and the rabbits that invades or that infects the rabbits. So the rabbit here being the host and the pathogen, the virus, myxoma virus. So there are several examples we can talk about. There are so many diseases, malaria or plasmodium and man. Plasmodium and man. So man becoming the host, plasmodium the pathogen. So we can also go through others very quickly. Symbiosis. Symbiosis, we've said, is a relationship in which two organisms benefit from the relationship. So organism A benefits. Organism B benefits. But now, if we used an example that we have been able to go through rhizobium and legumes. So we ask ourselves, there are several examples, so we look at the benefit of rhizobium. The benefit of rhizobium, we are able to say that it fixes nitrogen. Fixes nitrogen. We found out that this is the process of converting nitrogen gas to compounds that can be used by the plants. In this case, nitrates and ammonium compounds. We call that process as nitrification. And then for legumes, how will they benefit from, or how will legumes assist or aid the rhizobium? We said they provide shelter because it becomes a habitat for rhizobium because of the nodules. Remember, we drew a diagram just to show that if that's the root, that rhizobium will be living in that swelling that is found on the root. So it is providing shelter. But at the same time, as it does that, the legumes being plants, they photosynthesize, producing food, carbohydrates. So legumes provide carbohydrates in this relationship. Then we had a commensalism. Commensalism. We said in commensalism, one organism A will gain, but the other organism B neither gains nor loses. So if we use an example, then it becomes very easy. So this one benefits, but the other organism neither benefits nor loses. We can give example here. We talked of a flock of cattle. In that field, you'll always find white birds, the egrets. So how does the egret benefit? We said when the cattle walk through the pasture land, they are disturbing the ecosystem. Therefore, the insects that were hid in the vegetation will come out and they are able to be fed on by the egrets. So, disturbs ecosystem, releasing or exposing insects to be fed on. And then here, because the cattle neither loses nor gains, we just leave it that way. So there are several relationships, but we have just mentioned but a few. So let us go to another concept, size of population. Now we've been talking about communities and environment. So we cannot talk about communities without talking about population. Remember we talked about community. We said is where a community is when we have different species and occupying the same ecosystem. But before it forms a community, we must have different species, A, B, C, and then we have several of these species A, several of those species B, like that, So if we have members of the same species A or of the same species B and occupying the same, a given ecosystem or a given habitat, then we call this a population. So this is population. 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 But now if the three are living in the same ecosystem, it forms a community. A community. So that clarity must be there for us to move on. So I want to talk about population, sizes of population, some factors that may affect size of population. So I've said population is where same or members, where members of same species occupy a given habitat. A given habitat. So if we are going to have elephants, maybe elephants, same members of the same species living in a game reserve somewhere. That's their habitat. This one becomes a population. They are of the same species. But it should be noted that population size of organisms does not remain constant. It's never constant. It usually, most of the time it's increasing, but not exponentially. There's always a circle of rise and fall, but as it moves up. So in other words, if that is the case, if this is the population, and we have time on this axis, population will always increase at first exponentially, and then reaches a point where it is never constant, but it oscillates. We have those circles of rise and fall. We have the rise and fall. So within this band, within that band, it is as if it is constant because the range is small. Maybe there were fewer elephants. If you are going to use that example, there were fewer elephants. There was enough food supply. They were able to adapt to the ecosystem, and then they started producing. There was an exponential increase. But it reached a time, the elephant population, if maybe there are 100, it oscillates. It goes up, down. Maybe 1 or 5, it comes down to 96 within that range, and it continues its time for that purpose. It is because of the carrying capacity concept. Organisms cannot grow beyond, the population of organisms cannot grow beyond the carrying capacity of the ecosystem. So they'll fluctuate within that range. So in essence, we should note that the population of, or population size of organisms is never constant, but it usually fluctuates. So the question is, why does it fluctuate? Population of organisms does not remain constant. But fluctuates at carrying capacity. So it's going to fluctuate at carrying capacity. We can use that small illustration of graph to get it. So if that is the population, that's time, maybe in years or months. Remember, this is the y-axis, x-axis. Any illustration of graph on population, you don't start at 0, because you cannot have 0 population and then it increases. It means there were no organisms to reproduce. Therefore, it must begin slightly at that point, slightly up. So there was slight growth, exponential growth, but now it reaches a time, it does not go beyond, but it oscillates. We have circles, circles of rise and fall, circles of rise and fall. So it is not constant, it's not a straight line, but there is dynamism. So our question today, why do we have those fluctuations? So population fluctuates due to several factors. Population usually fluctuates due to some factors. Now, some of the factors are natural factors, as we are going to find out, but others are deliberately caused by human beings. They are called anthropogenic factors. Anthropogenic factors. For instance, logging, clearing a forest to establish a road or to establish a recreation center. So now, of these these categories, for the natural one, the most common factor that will cause change in population are the seasons. Seasons. Now, when you talk of seasons, you can have maybe a wet season. When it is wet, it comes with maybe cool environment or cool temperatures. The temperatures are low. Or it could be dry season. This one comes with high temperatures. Let us use quantitatively low, then high temperatures. It may come with high temperatures. Now, this is common for the tropics, where the season could be divided into wet and dry, tropical regions. But in other cases, seasons could be into 4. Like in Australia, we have 4 seasons. We might have a season like spring, season like summer, in that order. The autumn, and then we have winter and winter. Now, these differences in seasons usually come with different conditions for growth of specifically plants. If we go to Australia, for instance, or let us begin with the tropics, where we have wet season. During wet season, there'll be more plants growing. Growth rate of plants will be more. So because most of the plants form food for animals, so we expect, again, the population of animals to go up. So during wet condition, that's what happens. There is an increase in population of plants, which in turn leads to increase in population of animals. But during dry conditions, the population of plants and animals, the growth rate usually decreases of animals. Remember, dryness comes with decrease in amount of water. High temperature, as we are able to find out, it affects activity of enzymes. Some of the enzymes become denatured. So plants growth will be affected, few plant growth, and animals also. So in the end, there's a drop in population of plants, there's a drop in population of animals. Now, if we go to areas that has these 4 seasons, like in springs, we have the fastest growth of plants. And we have said where there is more plant growth, we expect more animals. So we are going to have more plants. And remember, it has just come from winter. Winter is a very cold season where nearly the temperatures are very low, therefore enzymes are inactivated. So once the sun starts to come in or the temperature starts to rise, the plants will make use of that cold condition. They'll grow very fast. In fact, some are able to produce flowers within that period, short period, and seeds, or together with fruits, so that it can make most of the very good conditions at that time. But during this time, because most of the plants have grown and we have more animals at that point during spring, summer and autumn, we have fast growth comparatively. It is fastest, but this is fast. Then in winter, we have slow growth. So we expect population during summer to increase. We shall have sprouting of many plants, which attracts more animals. There is flowering at that point, there is seeding, there is fruiting, just to make most, to utilize the conditions very well. But in summer and autumn, there's fast growth. It cannot be compared to this. But now in winter, when the temperatures are very low, there is slow growth rate, leading to fewer plants and fewer animals. So that's how the seasons can affect population sizes. So in our next lesson, we shall just find out what brings about changes in the season, or what brings about seasons, like revolution and inclination of the earth to the sun. Thank you.